page. Okay, so let's kind of talk about in general. Tangent is what over what function? Good. Sine x over cosine x. And then what is cotangent? Cosine over sine. Okay, the transformation is kind of the same as before. AHK period is the same, except for tangent and cotangent, it's a little bit tricky. The period is going to be pi over absolute value b, not 2 pi. Okay, for tangent and cotangent, it's half of the period of sine and cosine. Okay, let's talk about how to graph these. Tangent. So we just said tangent is sine over cosine. So what's going to create the asymptote when what happens? If you know, Yes, cosine is 0. When cosine is 0, then the whole denominator is 0. That's going to be a problem. So we're going to graph cosine. We want to know where the problems are. So we're going to just graph a regular cosine again. So you should know how to do this very quickly now. So do it really fast. Just graph a regular cosine. Okay, again, same as before. Wherever it crosses 0 is going to give me the asymptote. So draw your asymptotes. Okay, so at least that much. The next thing is, this one's a little bit harder. That's why we save it for last. Between the two asymptote is the starting point of tangent. So between the two asymptotes, right in the center, is where you're going to start tangent. So you're going to put a point there. That's the starting point. The next part is between the starting point and the asymptote. So half of that is where you're going to start drawing the tangent graph. Tangent graph is always increasing. So then half of that, this is where you're going to start. It's going to go up to the amplitude. The amplitude is 1. So half of that, that's going to go up to 1. And then half of this, between the starting point and the asymptote, this point is going to go down to -1. Okay, so you're going to have the points like this. And it's increasing graph. It's an increasing graph. Tangent is increasing. So please do not draw a diagonal like this. That's not what it is. You have two asymptotes, and then if you recall, asymptotes are kind of like magnets. It's drawing the graph towards it really, really close. So then your graph is going to curve like this. Okay? Let's try another two asymptote. Between the two asymptote is the starting point. Between the starting point and the asymptote is where it's going to go up to the amplitude or go down. This one is going to increase because it's tangent. So you're going to go up to here and down to here. Okay, let's say you just can't remember that it's supposed to look like this. Then there's also always another way of figuring this out. So you see, let's say we're talking about this point. You see here, this is pi over 4, right? We're basically asking ourselves, what is tangent pi over 4? Tangent pi over 4 is sine pi over 4 over cosine pi over 4. And we know that sine pi over 4 is square root 2 over 2. Cosine pi over 4 is square root 2 over 2. Therefore, that's 1. And that's why you put a 1. Pi over 4, 1. Okay, tangent of this is 1. You're just graphing all the trig ratio. Does that make sense? So if you just forgot how to do it, just put the numbers in and you can figure that out. Any questions? For people who are new, no questions? Okay, maybe just more practice. Okay, cotangent. Cotangent is what function over what function again? Yes, cosine over sine. So what's going to give us the asymptote? Good. When sine is 0. Yes. So we're going to start by graphing sine. Okay, so again, just a normal sine. Okay, from the normal sine, again, what you're looking for is where the asymptotes are. The asymptote is where the graph is at 0. Okay, just like the tangent graph, halfway between the two asymptotes is where you're going to start. So I'm going to pick these two middle asymptotes. I'm going to start in the middle. And then cotangent graph is a decreasing graph. So it's going to go, it's going to decrease. So then halfway between the asymptote and the starting point, it's going to go up to the amplitude and then down to the amplitude. Okay, again, pick another two asymptotes. Halfway in between goes up to the amplitude and halfway in between goes down to the amplitude. Remember that cotangent is a decreasing graph. Okay, let's do maybe one practice. Okay, let's have you try 2 cotangent 2x. 2 cotangent 2x. So you're going to graph, okay, cotangent 2x is going to be cosine 2x over sine 2x. So you're technically going to graph sine 2x because it's in the denominator, but you're going to know that, or remember that 2 is still in the front, so it's kind of stretching the graph by 2, so then when you do the amplitude, you still have to think of a 2. You don't have to graph the 2 sine 2x because it really doesn't matter. You only care about where it crosses the 0. Anyways, too much information. So go ahead and graph, and then let me know when you're done. So you're going to graph sine. So that's just trying to figure out where the asymptotes are, which is every pi over 2. Halfway in between, starting point. Halfway in between, go up to the amplitude. I know some of you just start drawing it without looking at the amplitude, but we should draw the amplitude because it tells us how much we're stretching. Okay, let's start at page 14. We're going to do the cosecant graph first. Okay, cosecant is 1 over what function? Sine. Good, sine. So there's a problem. Sine is in the denominator. That means we have a potential for issues. What's going to create something that is undefined? When what happens? When zeros, when you divide by 0. And what is going to give us a 0? Oh. When what becomes 0? When sine becomes 0. So when sine becomes 0, there's a problem. We're going to have undefined. And when it's undefined, we're going to have vertical asymptotes. Because when you divide by 0, it's usually going to create asymptotes, vertical asymptote. All right, so that means sine is the critical thing. We're going to graph sine first. Okay, this is a normal sine. Just, if you know how to graph sine and cosine, you have no problem graphing these 4 functions. Okay, so normal sine, amplitude 1, period of 2 pi. Okay, so go ahead and graph your normal sine graph. So just the normal sine graph, I'm graphing it in blue, and then I'm going to graph the cosecant in red, because the sine graph is just it's just a guideline. It's not part of the cosecant graph. It's going to tell me what my graph should look like, but it's not part of the final graph. Okay, so you can see that this is the sine graph. Wherever it crosses the 0, it's going to give us a vertical asymptote. So wherever it crosses 0, that's where I'm going to draw my vertical asymptote, because it's causing this function to be undefined. Okay, so I only use the sine as a guideline to tell me where the vertical asymptotes will be. The last thing is very easy. Cosecant graph, you're going to draw u's and downwards u's from the maximum and minimum. So at the top of the sine graph, I'm going to draw a u. On the bottom of the sine graph, I'm going to draw downwards u. And that's it. So the red parts are the cosecant graph. The blue is just a guideline. It's not part of the graph. Good. Okay. The next one is similar. It's secant, which is the same idea. Secant graph or secant function. Secant is 1 over what?
Cosine.
Good, cosine. So then what's going to create the vertical asymptote? When what happens? When cosine is 0, right? So when cosine is 0, we're going to have problems. So we're going to graph the problem graph, which is cosine. So we're going to graph cosine on the secant graph. So go ahead and graph your cosine graph. Okay, once you have the cosine graph, it's the same idea as before. Wherever it crosses 0, that's where we're going to have asymptotes, because you have 1 over 0, which is undefined. So draw your asymptotes, the vertical asymptotes. And then secant is the same as before. So wherever you have a maximum, you draw the u's, and then the minimum, you draw the downwards u. And that's it. So cosecant and secant are very easy. You just need to know how to draw the function in the denominator. Okay, now is the time for you to practice. Let's have you guys just try this one. 2 secant x over 2. 2 secant x over 2. You're going to think about which function you're going to start graphing so you can find the asymptote. So this one, you're going to graph 2 cosine x over 2 to start. Okay, so that means the period is going to be 4 pi. So 2 pi is going to be half of it. Pi is going to be the quarter. Goes up 2, down 2, and we're going to graph that. So the asymptote is wherever it's 0, and then you draw the graph. Okay. All right, we're going to have to skip some examples because of lack of time. So we're going to now go back to tangent and cotangent.